Yesterday, Netflix went down, then Reddit went down, PlayStation down, Roblox down, Fortnite down, Robinhood, Coinbase, Venmo, Snapchat, Disney, down. And that's just a small list out of the 2,500 plus companies that got wrecked after we experienced the most catastrophic cloud outage in history. What do all these apps have in common? Well, they're all addicted to AWS, Amazon Web Services, the biggest cloud in the game, with an estimated 350 massive data centers up and running around the world, and hundreds more being built as we speak. That means when AWS goes down, the entire world goes to hell. I nearly starved to death yesterday because the McDonald's app was down. I tried to DoorDash some food, but that was down too. Then I tried to order groceries on Amazon, but wouldn't you know it, Amazon.com itself was down. I tried to ask my AI girlfriend what was going on, but she runs on AWS. As I lay there starving to death, I tried to open Duolingo to ask the abuela next door how to cook food, but Duolingo was down too. Little did I know, because the New York Times was down, a single misconfigured DNS setting in US-EAST-1 had regressed society back 50 years. I only survived because I logged into X, which wasn't affected. Elon Musk and DHH had a field day with this incident, and in today's video, we'll break down the technical details that led to the great AWS cluster of 2025. It is October 21st, 2025, and you're watching the Code Report. As I mentioned, AWS operates hundreds of data centers that literally power the multi-trillion-dollar internet economy. I literally mean that literally. When you receive an unsolicited dick pic on Snapchat, it's Amazon, not Snapchat, that's the one using the electricity to process those pixels, as Snapchat just rents out space in their data centers. Now, all of these data centers get clustered into geographic regions, with the US-EAST-1 region in Northern Virginia being one of the oldest and perhaps most important. It lives next to the economic and cultural heart of the United States near DC, New York, Boston, etc. But a cloud region contains multiple data centers along with at least 3 availability zones for redundancy and fault tolerance. Like each zone has its own power, cooling, and networking, so if one gets blown up by a disgruntled programmer, everything should still work just fine, in theory. But in practice, things can still break massively for silly reasons. Here's the timeline. At 9:07 p.m. Eastern Time, AWS posted they were seeing increased error rates and latencies across multiple AWS services in US-EAST-1. Then they later narrowed the root problem to a subsystem related to DNS resolution for the API endpoints of services, most notably Amazon DynamoDB. I once made a video about it, but the DNS is like the phone book of the internet. That means for an app like Snapchat to work, it needs to reach out to AWS and say, hey, where's my database? A DNS lookup is performed, and because in this case it was broken, Amazon would say, sorry, I can't find your database on this address. And that turned all these software products into instant vaporware. But in this case, the failure had a cascading effect. Even though AWS was able to locate and fix the issue within a couple of hours, a massive queue of serverless jobs accumulated, like Lambda function calls and simple queue service messages. So apps continue to have problems for hours afterwards. As a Firebase developer, I'm one of the lucky ones who survived, but this incident is yet another example of why we probably shouldn't be relying on one company to centralize so much computing. Even companies like Supabase are pissing off their users with 10 plus days of downtime in the EU West 2 region. It's not Supabase's fault though, AWS just won't give them the capacity no matter how hard they beg. Supabase's only crime is not having a backup heroin dealer. And by heroin dealer, I mean big cloud. But the big question is, which developer can we get blamed for this outage? We don't know, but my theory is that they just pushed some bad AI code, and none of this would have happened if they were using Tracer, the sponsor of today's video. It's an agent orchestrator, which adds a layer of planning and verification that makes your coding agents a lot more effective. Just tell it what you want to build, and it will pull context from your code base and ask you follow-up questions to create a detailed implementation plan that is broken down into phases. Once you approve the plan, you can pass it off to your favorite coding agent, and it will generate code that actually does what you want. After it's finished, Tracer scans all the changes and flags any issues, so no slop actually makes it into production. It's especially useful when working in larger code bases, which is probably why a surprising number of developers already seem hooked on it. But you can get your first hit for free by going to tracer.ai and signing up for a 7-day trial. This has been the Code Report. Thanks for watching, and I will see you in the next one.